So the next lab that we're going to move into is label switching. And one of the key concepts of label switching, or at least it works in conjunction with MPLS label switching, is something called virtual routing and forwarding, which we call VRF. Now, a VRF instance is basically a self-contained routing table within the same router. So let me just open up our Nexus switch and show you something. If I was to say interface E1/1, IP address of 10.1.1.1/24, no shut that interface. Then on the same router, if I was to say interface E1/2, and let's say an IP address of 10.1.1.1.2/24, and if I say no shut, we can see that we come up with an error message here. Basically, it's saying, please change the IP address to avoid overlap and perform a no shutdown. Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the Play Special. Do you want to know what the Play Special is? Press like and subscribe. Okay, back to the video. What we're seeing is that in the routing table, there's a conflict of interest. So if I say show IP route, within the routing table, if I say show IP interface brief, we see that 10.1.1.1 came up, but 10.1.1.2 didn't come up. And the reason is they're both in the 10.1.1.0/24 network. So it would basically be saying, like, how do you get to this network? It's either via 10.1.1.1 and it will also be via 10.1.1.2. The CPU's got enough issues to worry about. It doesn't need to regard these conflicts. But there is a way to get around this. As I said earlier, we could use VRFs, where a VRF is a self-contained routing table within the same router. So let's have a look at the topology that I'm going to be using. This is the topology that I'm going to be using. Now I've got customer A with R1 and R2 connected to our Nexus, and customer B with R1 and R2 also connected to the Nexus. And just to make things a bit more slick, they've both got the same IP addressing and they're both advertising the same prefixes. So if I go back onto our Nexus and if I say show VRF, we can see that on the Nexus we have two VRFs by default. We have the management VRF and we have the default VRF. What I'm going to do, I'm going to create two additional VRFs, one called VRF Red, one called VRF Blue. And what I can do is then I could use overlapping address ranges, and they're going to be completely segregated in their own routing table on the Nexus. So customer A, R1 will be able to ping customer A, R2's prefixes and vice versa, without actually being able to, in its own separate routing table, it won't actually overlap with customer B's prefixes, even though they're using the exact same IP addressing. So let's do that. So I've already configured the host. So all I really need to do is do the configuration on the actual Nexus. So on the Nexus, to create our first VRF, we say VRF context red, and we could also say VRF context blue. Now what happens when you add an interface into a VRF, it strips out all of the layer 3 addressing. So let's have a look back at the diagram. We can see on the Nexus we've got E1/2 and E1/5 are both in VRF red for customer A. And we can see that we also already have some VRF configuration on Ethernet 1/2. So let me add that into VRF red. Interface E1/2, VRF member red. And we can see that we see a message come up here saying deleted all L3 config on interface Ethernet 1/2. So if I was to say show run interface E1/2, you can see that that has now been taken off. Now what I'm going to do, I'm going to do the configuration on interface E1/5. So interface E1/5, let me look at the diagram again. That's using .9. So I'll say IP address 10.1.1.9 10.1.1.10/29. Now, if I didn't want it to actually strip off the IP addressing when I add the interface into a VRF, I could use the following command. I could say system VRF member change retain L3 config. Now, when I say interface E1/5 VRF member red, when I do a show run interface E1/5, we can see that the IP addressing remained. All I have to do now is do a no shut on that interface. And also I need to, there's a duplicate IP address. That probably means that on the actual host, I've got 10.1.1.9 and I should have 10.1.1.10 looking at the diagram. So let me jump onto customer AR2 and just do a change of that IP address quickly. So customer AR2 here, show IP interface brief. Yeah, there we go. So conf t interface G0/0 IP address is 10.1.1.10 on a /29, which is 255.248. And that should, let me just save that config as well. That should get rid of the conflict. Jump back over to our Nexus. Let's do a ping on this. So ping 10.1.1.10 in VRF red. Yeah, and that's come up. We also need to do that same configuration on interface E1/2. So all I need to do is interface E1/2 IP address of, again, I'm going to look at the diagram. So it's .2 on the Nexuses and .9. Okay, I won't forget that again. So IP address 10.1.1.2/29. Okay, now shut that interface. Can I do show VRF red interface? Yeah, and we can see that for VRF red, we have interfaces 1/2 and 1/5. Okay, that's excellent. And I'm going to do the same for VRF blue now. And VRF blue is interface 3 and 4. So interface E1/3 to 4. I'll make it a range. I'll just say VRF member blue. And then interface E1/3. Come on. Interface E1/3 has an IP address of 10.1.1.2/29. No shut the interface. Should have done that under the range. And interface E1/4 has an IP address of 10.1.9. And no shut that interface. Show. And again, there's a duplication. So again, on the host, which is customer BR2, interface G0/0 IP address 10.1.1.10 on a /29. No shut. Okay, excellent. Alright, so if we jump back onto the Nexus, we should be able to ping the directly connected interfaces, but we won't be able to ping the actual loopbacks. And to be able to ping the loopbacks, we're going to have to use either static routing or a dynamic routing protocol. I'll probably use OSPF, but let's see if we could do the direct connection first. So the first thing I'm going to do is ping in VRF red. I should be able to ping 10.1.1.1 and 10.1.1.10. So ping VRF, oh, is it at the beginning or at the end? Ping 10.1.1.1 in VRF red. Okay. Show IP interface brief for VRF red. Yeah, our local addresses are 10.1.1.2 and 10.1.1.9. So let's ping 10.1.1.10 in VRF red. That's directly connected. And let's do the same test for VRF blue. The first one is ARP. Yep. And 10.1.1.10 in VRF blue. Now these are actually advertising, let's do a check on that actually. Are they advertising in OSPF? Do show IP route. Okay, do show IP OSPF interfaces. Let's see if they're advertised in OSPF. I don't have them advertised in OSPF, so let's just do that quickly on all of them. Router OSPF 1, all networks, network 0.0.0, 0.0.0, area 0, and this needs to be on all of these, so let's just take this. Do show IP OSPF interface. Brief. All of our interfaces are advertised. So let me take this network command and add it on all of the hosts very quickly. So customer blue R1, do show IP OSPF interface brief. I'm messing that up. Router OSPF 1. On all of them actually. Router OSPF 1. Router OSPF 1. Alright, they've all been advertised into OSPF. Now I still shouldn't be able to see them because I don't have any OSPF here on the Nexus switch. So if I say show IP route for VRF red, yeah, I don't see these loopbacks, and do the same for VRF blue. No. So now what I need to do is actually get a OSPF connection to those loopbacks for each individual VRF. So the way I'm going to do that is, first I will enable OSPF, so feature OSPF, and then what I could say is router OSPF 1, and do I do it here? VRF, yeah, VRF blue, so VRF blue. What else do I need to do? Do I need to do any area commands here? Maybe not. I think what I can do, I could actually do it under the actual interface. I'm hoping I could do it like that. So if I now say interface E1/2, comma, E1/5. Oh, I missed out the one. So interface E1/2, E1/right, IP router OSPF 1, area 0, no VRF information here, IP. I think what I need to do is under the OSPF process, so let's try that again. If I say router OSPF, let me just call that red, router OSPF red, and if I say VRF red, then if I go under the interface E1/2, comma, E1/5, and if I say something like IP router OSPF red, that's in area 0, yes. Okay, that looks good. And I will do the same for the other side. So if I now say router OSPF blue, and I say that is for VRF blue, and that is for the interface ranges of E1/3 to 4, and I say IP router OSPF blue, and then I check to see if this has adjacency has come up. So show IP OSPF interface brief first, and then neighbors. Show IP OSPF for the VRF of red interface brief. Alright, let's just show IP OSPF VRF red. See if it shows me any interfaces there. Well, it's showing me that it's advertised for area 0. So show IP OSPF red int brief, nothing. And show IP OSPF blue interface brief, again, nothing, which is not looking good. So show IP root for VRF red. Anything came up there? Well, they're advertised, which is good. And show IP root for VRF blue. So it's definitely working. But what are the verification commands? Show IP OSPF. My process tag is blue. What else do I have on the end of that? Neighbors. Let's try neighbors. Alright, for VRF blue. Right, I need to put the VRF on the end. That's superb. So my neighbor is 2.2.2.2 and 4.4.4.4. Excellent. And let me say our interface brief to see what interface is, even though we can see it on the end here. Interface brief for VRF blue. Yes, superb. And let me do a ping of that. So ping 1.1.1.1, which is R1's loopback in VRF red, and it's reachable. The exact same IP address, but in VRF blue, that is also reachable. So what I should be able to do theoretically, I should be able to jump onto customer A for R1 and see customer 2's loopbacks. They don't have any concept of the VRFs. So let's go into customer 1. And if I now say, do show IP interface brief, do show IP root, and we can see that we have 3.3.3.3 available and 3.3.3.3 available and 4.4.4.4. Do ping 3.3.3.3. We have reachability and do ping 4.4.4.4. We have reachability. The last test is to actually do the same ping from customer B. So we jump onto customer B, do ping 3.3.3.3, which is customer B R2's loopback, and do ping 4.4.4.4. Superb. And what I could also do, if I do something like a do show IP interface brief, not a do on the Nexus, sorry. If I just say show IP interface brief, VRF all, and we can see all of the interfaces, and we can see that I left this 10.1.1, that's in the default routing table, so it won't affect anything. And then we have in VRF red, we have Ethernet 1/2 with an IP address of 10.1.1.2 and Ethernet 1/5 with 10.1.1.9. And in VRF blue, we have different interfaces, but with the exact same IP addressing. All right, thanks for that. If we've got a good overview of VRFs, we're now in a suitable position to move into label switching, MPLS label switching. So I'll see you in the next video.